All right, folks, we're going to take a look now at a third example of solving an exponential equation. So here we take a look at this example here, and we look, it's actually very similar to the one we solved earlier, okay? The only difference here is I can't use the same exponent law as before, because here I had 4 to a sum. So I was able to use that first exponent law to turn this into a product of two powers. Okay, here I have 5 to the 2x, so I've got a multiplication, but I can use the third exponent law. So I have a choice here. I can write this as 5 squared to the x, okay, because 2 times x, 2x, or I can also write it as 5 to the x squared, okay. Again, by the commutativity of multiplication, 2 times x, x times 2 is the same thing. So which one to choose? Well, remember what we talked about before is what you want to try to do is you want to try to get your expressions to have the same power. And here I already have a 5 to the exponent of x, so I think it makes sense to choose this second one. So I'm going to rewrite this now as 5 to the x squared minus 5 to the x minus 12 equals 0. Okay, so now let's take a look at this expression here on the left, and I realize that I have a squared term minus a non-squared term minus some constant. So I'm hoping you're going to see that this looks a lot like a trinomial, in fact a quadratic trinomial. Okay, and so what I'm going to do is I'm going to use an old trick to help me see that a little more clearly. So I'm going to make some new variable be equal to my power 5 to the x. And so this can be rewritten as z squared minus z minus 12 equals 0. And now I realize, hey, I can just factor this left-hand side. It's already equal to 0 on the other side. So let's say I had 5 to the power of x squared minus 5x equals 12. Hopefully you would have seen that you want to bring everything to one side of the equation, get 0. So here, if I'm lucky, this factors. If not, I can always use the quadratic formula, but this does in fact factor quite nicely. Z minus 4 times Z plus 3 is equal to 0. And so that means Z can be equal to 4 or Z can be equal to negative 3. But of course, I'm not solving for Z, I'm solving for X. So at this point here, I'm going to replace Z by 5 to the X. Okay, so here, well, I can't rewrite 4 easily as with a base of 5, so I'm going to use log base 5 of both sides. So here I end up with x equals log base 5 of 4. There's one of my answers. Okay. Now I look at this one here and I realize, hey, wait a minute, 5 to the x. It's an exponential function. An exponential function can never be negative. So this here is impossible. There's no solution that comes from that there. Now let's say I didn't see that right away and I took log base 5 of both sides. I would have had log base 5 of negative 3. Hey, we can't take logarithms of negative numbers. Okay, so you should have gotten to the same conclusion even if you did take log base 5 of both sides. And so this equation here has this sole answer. Okay, so let's recap. So again, as we did before, look to see if you can use an exponent rule, okay, to write all the powers having the same base and exponent. In this case here, we were able to write all the powers using a 5 to the x. And then here we see that we can set up solving the equation using a quadratic trinomial, okay, just as we had seen before. Okay, that's it for this one.